I'm going to look here at our DPT8 project where we're supposed to be finding the exact solutions using factoring method, square root method, and quadratic formula. So the equations that you see here on my screen for DPT8 are going to change and be refreshed next time you open DPT8. So I'm going to look through the examples as they were, and then if you want to try this project again, there will be new equations on your Canvas course for those. All right. So my goal is to solve the first equation using the factoring method. I want to factor, I want to solve for the zeros, and then graph them. When I graph the zeros, what I'm actually graphing is the x-intercept. So if I graph the zeros as ordered pairs, those will be the x-intercepts. That's what I'm looking to do. All right, so I'm going to do most of this here in decimals. So I'm going to start with my f of x, and I want to get it in factored form. So I'm going to make myself some notes. I'm looking for two numbers whose sum is the middle value, 5, and whose product is the product of a times c, so 2 times -3 is -6. So the two numbers with the sum and product are going to be, I think I'm going to need a +6 and a -1. That way it adds up to a +5 and also multiplies to a -6. So when I factor this, I'm going to separate that middle term from 5x to 6x minus x. And I can write some of this work in a regular expression line instead of in a note because I can just double check that what I've done to the graph hasn't changed it. So I'm going to write this in a regular line right here. Oops, I'm going to copy. And then I'm going to begin factoring. So if I look at the first two terms, I'm going to try to decide what is in common between those two terms. So they both have a 2 and an x in common. And if I take the 2 and the x out, it would leave me with x from the first term and +3 for the second term. So there was some weird stuff going on with my graph as I was still typing. But once I finish, I can see so far so good, haven't changed. Now this piece. When I factor that piece, I'm going to notice that they have a -1 in common, so I'm going to take -1 out, and if I divide that out, I'll have an x +3. Okay, so we're still in the midst of the factoring process, not fully factored yet, but I can see that the x +3 is the binomial in common, and once I factor that binomial out of both of these, what would be left would be the 2x minus 1. So that is now factored. So this is the factored form of my function f of x. Just going to announce that fact by putting f of x again in front of it. Now I'm fully factored. That's a new way of writing f of x. So I have a few things right here that are showing my work for factoring. Now I'm going to get my zeros by setting each of these equal to 0. I'm going to do this in a note. So I'll have x +3 is equal to 0, or we would have had 2x minus 1 equal to 0. So x would be equal to -3 in the first. In the second, I'd have 2x equals +1. And if I divide both sides by 2, that would give me x equals 1/2. So my zeros are at -3 and 1/2. If I graph those zeros as ordered pairs, that means the x-intercepts, right? So I'll have -3, 0, and I will have 1/2, 0. And I can click the label box for my ordered pairs, and you can see now in the graph, I haven't looked at my graph a ton yet. I'm just now checking that my x-intercepts or my zeros do match up with where the function crosses the x-axis. Okay, so we were able to factor, and once factored, solve, find those zeros in exact form in the fractional form. All right, so done with this piece now on the factoring method. I'm going to minimize and turn off this folder to take a look at the next one on the square root method. Once again, I need to solve this, and I'm going to use a note to write what I'm doing here. I want to solve this equation equal to 0. So 4 times x minus 3 squared minus 8 equals 0. You can solve this on paper. I'm just trying to show my work right here on the screen. My next step would be to add the 8 to both sides. So I'm still going to use a note right here during my solving steps. So I have 4 times x minus 3 squared, add the 8 over, so equals positive 8. And then I have to isolate the square before I can take the square root of both sides. That is going to mean I need to divide off this 4. So I'll have, I still do want to note here, I'll have x minus 3 squared, equals, I'm dividing by 4, so I'll have 2. Okay. At this point, I'm ready to take the square root of both sides. I'm going to go out of a note right now just because it is difficult to type the square root symbol in a note. So if I take the square root of both sides, I'll have x plus 3 equals, and it will be plus and minus, which is very awkward to type. I can sort of type it like this, plus and minus, and that little weird fraction, it's not the best. And then it's the square root of 2. Okay, so I'm going to copy paste this for a second. I'm writing it not in a note just because it's easier to type the square root this way, but you can see that it's still not proper notation for how it evaluates something. I'm going to subtract this 3 to the other side. It's going to make it a negative 3. I'm going to put it in front of my plus or minus here. Now, this is not truly a plus or minus symbol, so forgive me for having that fraction bar in the middle, just one way that I can get the just across. So I can see that my two solutions are x equals negative 3 plus the square root of 2 and negative 3 minus the square root of 2. So those are my two solutions without that weird plus or minus symbol I had to manufacture. Now, it's still giving me triangles here. I don't mind the triangles. These are sort of all notes right here, so I'm not trying to do anything on these lines. I'm just trying to express my solutions in a way that is readable. When I get to the end, I do want to graph my solutions as ordered pairs or as the x-intercepts. So I'm going to do negative 3 plus the square root of 2, comma 0, and negative 3 minus the square root of 2, comma 0. If you were curious on this one, by the way, just a second, I just realized I made a mistake up here. I accidentally wrote down a plus instead of a minus, so you have to wait while I change that real quick. That was supposed to be a minus, which would have meant I added 3 to both sides. And these 3's are actually supposed to be positives. Apologies, I didn't realize that I had made that mistake until I saw my x-intercepts and I saw they're in the wrong spot. So we can correct that mistake real quickly. That was supposed to have been a positive 3. Now I can see that I made a mistake. So this is one of the advantages of being able to graph my solutions against my equation, so I can make sure that they are truly solutions to the equation. And my mistake had happened when I translated between these two lines. I had used an incorrect symbol there. So we fixed that now. Okay, so I've got the solutions to this one. I'm going to minimize this graph and get into the quadratic formula. Right. So I'm going to make a note for my a value, which is 1, my b value, which is negative 4, and my c value, which is 1. And then I'm going to go ahead and type the quadratic formula. Negative, negative 4, and it is plus or minus here. I'm going to argue that right now I want to use just plus, remembering that I need to do both, and I'll copy paste and I'll do the minus 1 after I finish the plus 1. So I'll just do plus the square root of b squared, so this is negative 4 squared minus 4 times a, which is 1, times c, which is 1 over 2 times a, which is 1. So if I just do one at a time, I can see the numeric value for it. I just need to go inside my folder, and I can start to simplify this. So I know that negative 4 is 4. I know that 2 times 1 is 2. And I can grab this bit, the bit inside the radical, and I can evaluate that and find that the number inside the radical is 12. So that's going to allow me to help simplify this right here. I can go a little further on this if I copy paste that again. And I can rewrite the square root of 12 as the square root of 4 times the square root of 3. Noticing that I have the same decimal value each time helps me observe that I have not yet made any mistakes in transferring this value. So it's pretty handy. Back up here, square root of 4 is 2. And then I can simplify this even further by noticing that I can divide all the coefficients 4, 2, and 2 by 2. So 4 divided by 2 is 2 plus or minus the square root of 3. And it's not divided by 2 anymore since I divided 2 divided by 2 to get 1. So I now have one of my solutions, and I know that both of my solutions are x equals 2 minus and 2 plus the square root of 3 and 2 minus the square root of 3. So I waited until the end to add my plus or minus so that I could be checking throughout my work right here that I was getting the correct value, that I was not changing it each time. So I've got my solutions, and now we're going to do our last part, graphing them as ordered pairs. So we'll have 2 plus the square root of 3, comma 0, and 2 minus the square root of 3, comma 0. And those 2 points go through the graph. On the graph, I only see them in their decimal representation, but I can still verify that the points that I have chosen are correct. They are the x-intercepts or zeros of this function.